right, guys, going to do an example of graphing a hyperbola here where we have to complete the square to put the hyperbola in standard form. So really completing the square will help us to figure out what we're graphing. Make my screen a little bigger here. So I'm going to start off by just grouping our x's and y's together, and it's up to you whether you like to move the constant to the other side. I am going to move that 325 over. So I'm going to group my 9y squared. There's no other y's in this one. I'm going to group the x's and also factor out the coefficient. All right, and now I'm going to complete the square. If there was another term with a y in it, we'd have to complete the square twice. But for this one, we're safe. Only the x term, we have to complete the square. And I do that by taking the middle value, 4, dividing it by 2, so that's 2, and squaring it. So I get another 4 there. Now, remember, whatever I do to one side, I have to do to the other. So we've got this negative 25 that's really being applied to that 4. So on the right side, I will also be subtracting, since it's negative 25 times 4, so minus 100. And now I'm going to factor what I can on the left. So I've got 9y squared minus 25. Here is why we completed the square, so I can factor this, equals 225. Finally, to get our standard form, I'm dividing everything by 225, so we have a 1 on the right side. So these luckily go into very nicely. I think this guy should be a 25 is what I have. Let me grab my calculator to be sure, though. Yep. And then 25 goes into 225 9 times, just the opposite. All right, so let's start graphing. From here, we have our center. Make sure you're taking the x value first. So that's going to be at negative 2, 0. My a value is always in the positive fraction. So that should be the first fraction if we're writing it in standard form. So a is going to be 5. And since it's under y, this is a vertical hyperbola. It's going to open up and down. So I'm going to go up 5. 1, 2, 3, 4, 5. And get our vertices. And down 5. 1, 2, 3, 4, 5. So actually list the vertices for this one. They're going to be at negative 2, 5, and negative 2, negative 5. All right, I'm going to graph our asymptotes using the b value. Here's b squared. So that'll help me find the length of our conjugate axis. And I actually like to go to the vertices and just go to the right and left. Since this guy's opening up, I'm going to go the opposite direction. To the right and left, 3. So 1, 2, 3, that's our b value. 1, 2, 3. So I can make this big rectangle. 1, 2, 3. And it's up to you if you want to actually draw it in. You don't have to. You can just take your center and go to that point you created. Doesn't have to be perfect. Just best you can. And then we can fill in the hyperbola. So remember which ones are your vertices. This one opened up and down since it was our y was a positive fraction. So my hyperbola would follow right along. Oh, I wanted to match the vertex color. Follow right along these asymptotes. All right, so since I did that, I'll actually write out the equation of the asymptotes first. And our slope, we went up our a value and then over our b value. So I'll have plus or minus, a was 5, b was 3, and I'm going to use point slope form with the center. So my center point is negative 2, so x plus 2. And y we didn't have any values, so that's just going to be y equals. Okay, so we've got center, vertices, asymptotes. Last thing is to find our foci, and to do that, we need our c value. So I'm going to do a squared plus b squared equals c squared, essentially adding up our denominators. So that's going to be 34 for this one. So c equals root 34, which makes our foci. We're going to use the center, but we're going up and down, c, like into our hyperbola. So root 34 is just under 6, right? So 1, 2, 3, 4, 5, really close to my vertex. Those would be our foci. And the equation would be 2 plus or minus root 34, or the point, right? Points for the foci. Once we have that, our eccentricity is just c over a, so root 34, divided by our a value, which is 5. All right, guys, so there's an example of graphing a hyperbola. You guys can try out the other ones and make sure to check your answers.